All right, yesterday we talked about double angles and dealing with formulas with the double angles. Once again, those should be down on your notes. Today we're going to deal with half angles, working through half angles. But what we will utilize is we will use the double angle formula for the cosine of 2a for all of our half angle ones. So if we take a look at our cosine of 2a, yesterday we described it. Cosine of 2a was cosine squared minus sine squared of a. But then we gave two alternate forms to this as 1 minus 2 sine squared of a and 2 cosine squared of a minus 1. And what we're going to work on is we're going to basically deal with those two alternate formulas for the cosine of 2a to work with the half angles. Now when we are dealing with double angles, we are multiplying the angle by itself or adding it to itself. We have a 2 times a or a plus a. When we're dealing with a half angle, we're taking an angle and we're dividing by 2. So we have some angle, so we're going to let x be any angle. So x is going to be any angle. We're not going to use a here, we're going to use x. Because we've already used a, and we're going to use the a formulas here. So we're going to let x be any angle that we want. So when we multiply by 1/2, we get half of this angle, which is equal to this angle divided by 2. So we can have either form of this, angle divided by 2, or we can have 1/2 times the angle. You'll see them both in a book. You'll see when you go online or whatever, you'll see both of these formulas for your half angles. So what we're going to look at here is we're going to look at the cosine of, we're going to look at the cosine of half angle, sine of half angle, and tangent of half angle. And once again, the reciprocal functions, we can just flip these things over. The first one we're going to look at is we're going to look at the cosine of 2a is equal to 2 cosine squared a minus 1. Okay, that's one of the formulas that we developed yesterday with our double angle formulas of the cosine. And what we're going to let x equal, or let a equal, we're going to let a equal this 1/2 x or x over 2. Once again, does not matter. So wherever I see an a here, I'm going to put in this x over 2. So we have the cosine of 2 times x over 2 is equal to 2 cosine squared x over 2 minus 1. So wherever I saw an a, I'm just putting in half x or x over 2. Once again, either way is the correct way of looking at it. Well, if we take a look at the left-hand side, we have 2 times 1/2 x. What happens so nicely here is the 2's will cancel out, leaving us with the cosine of x is equal to 2 cosine squared x over 2 minus 1. If we add 1 to both sides, so we're left with 1 plus cosine of x is equal to 2 cosine squared x over 2. Get rid of this multiplication by 2, we can divide by 2. So these go away. So what we're left with is the cosine squared of x over 2 is equal to 1 plus cosine of x all divided by 2. I just switched sides with the cosine because what we're trying to ultimately solve for is a formula for the cosine of half x. So I just switched sides here. Our last step, to get rid of a square, we could take the square root. So what we're left with is we're left with the cosine of x over 2 is equal to plus or minus 1 plus the cosine of x, all divided by 2. And what we'll have to eventually do, and we'll talk about this, is that plus or minus, you're going to have to make a decision. Do we use the positive or do we use the negative? But this is the cosine of a half angle. We have x angle divided by 2, or we could write this as cosine of 1/2 x. Either way is correct. Once again, x over 2 or half x is half of an angle. Alright? Once again, something that you should add to your identity sheet. Now we're going to take a look at the cosine of 2a is equal to that other form of the double angle, 1 minus 2 sine of a divided by 2. And we're going to let a, once again, equal this 1/2 x, or x over 2. And we're going to make our same substitutions we just did. So this is going to look very similar to what we just did. Cosine of 2 times x over 2 is equal to 1 minus 2 sine squared x over 2. So we've made basically the same substitutions we just did in the previous problem. Once again, on the left-hand side, the 2's are going to cancel out. So we're left with the cosine of x is equal to 1 minus 2 sine squared x over 2. Our next step is what I would like to call a Gregoryism. We're going to do what I call the double switcheroo. The double switcheroo. The reason why is we want to get, it's a little bit cleaner if we can get the sine squared of half x positive. And it's negative right now. So what we're going to do is we're going to move this over to this side, and we're going to take the cosine of x and move it over to this side. Now how we can do that is by subtracting cosine of x, and adding in your 2 sine squared x over 2, 2 sine squared x over 2. So we're adding this term to both sides, or we're subtracting this term to both sides. What I call, once again, the double switcheroo. Why? Because it just makes it a little bit cleaner for us to work with. So what we're left with now is 2 sine squared x over 2 is equal to 1 minus cosine of x, which looks very similar to what we just did from up above. We're going to divide both sides by 2, like we did above. These go away. So we're left with sine squared x over 2 is equal to 1 minus cosine of x, all divided by 2. Once again, to get rid of a square, we could take the square root. So we're left with sine of x over 2 is equal to plus or minus square root of 1 minus cosine of x, all divided by 2. Once again, the formula looks very similar. Now with the sine, we're going to be subtracting off the cosine. With the cosine, we're going to be adding it. Once again, this is half angle, which is sine of 1/2 x. Once again, either way, you'll see them both ways in a book. But this is a sine of half angle. If we needed to find the cosecant of x over 2, this would be 1 over sine x over 2. So we'd find the sine of x over 2 and we flip-flop it over. Once again, something that you should be adding to your identity sheet, your formula sheet. Tangent. The tangent we defined before is tangent of some angle A is equal to sine of A over cosine of A. Well, if our A is 1/2 x, half angle, the tangent of the half angle is equal to sine of the half angle over the cosine of the half angle. So we can write our formulas plus or minus square root 1 minus cosine of x over 2 all over plus minus square root of 1 plus cosine of x all divided by 2. That is just putting the sine of half angle divided by the cosine of the half angle. This is divide by, so we would flip and multiply by my reciprocal. We'd flip our bottom and we would multiply. What would happen nicely for us is these 2's would go away. So what we're left with here is the tangent of half angle is plus or minus square root of 1 minus cosine of x over 1 plus cosine of x. So this is your tangent of your half angle. Now, as we had with the double angles with the cosine, we had two alternate forms of the formulas. The tangent of the half angle, we can also have two alternate forms. We have this one, all three of them, they'll get your right answer. But I'll show you my preference in regards to it. Okay, this is our tangent of half angle. If we would multiply underneath the radical by 1 plus minus cosine of x, the top and bottom. Once again, what we are creating is we are creating equivalent fractions by multiplying top and bottom by the exact same thing. When we do that, we're not changing, we change the look of the fraction, but the fraction is still equal. So we're going to multiply top and bottom by that. So what we're left with is plus or minus on top 1 minus cosine of x all squared, because we have two factors of 1 minus cosine of x. So we have two factors of it, so we have 1 minus cosine of x quantity squared. On the bottom, if we would FOIL this out, we would have 1 times 1, which is 1. We'd have a plus cosine x and a minus cosine x would cancel out. But then what we're left with is minus cosine squared of x. Well, if we look back into our identity sheet and our formula sheet, we've seen 1 minus cosine squared. 1 minus cosine squared from our trig identities is equal to y. Well, the answer to that should be sine squared. So we have 1 minus cosine of x, quantity squared, divided by sine squared of x. Well, what we're doing is we're taking the square root of the squares. So if we take the square root of squares, what we're left with is another form for the tangent of half angle, which would be 1 minus the cosine of x over the sine of x, which is your 1 minus tangent, or tangent of half x. So this would be an alternate form, and to be quite honest, this is the one I utilize the most because I don't have to make a decision about the radical. Likewise up here, if we multiply top and bottom by 1 plus cosine of x, 1 plus cosine of x, rather than 1 minus, what will happen is we'll get another form and it will just be the reciprocal of what we just have here, except for we have plus on the bottom. We have sine of x over 1 plus cosine of x. Because if I multiply by 1 minus cosine, I have 1 plus cosine squared. On top, we're going to get 1 minus sine squared, cosine squared, which will give us back the sine squared. We take the square root. So once again, either one of these will give you a solution. Once again, I tend to favor this one a little bit more, and I'll show you why here in a minute. So if we take a look at our triangle, our problem, we have the cosine of theta is equal to negative 3/5, and theta is in between 90 and 180. So if we take a look at between 90 and 180, which quadrant would this be in? If I'm talking about between 90 degrees and 180 degrees, what quadrant would that tell us? Well, this would be 0, this would be 90, this would be 180 in our rotation, so this would be in quadrant 2, which I have drawn there for you. And what we're showing here is the cosine of this angle, which is, once again, just as our review of the topic, the cosine of theta reference would be negative 3 over 5. Cosine of theta is negative 3 over 5. So if I look at my triangle, I have negative 3, which is my adjacent. My hypotenuse would be a value of 5. Here's my angle theta. This is my theta reference. And hopefully we know by now our opposite side is a value of 4. Once again, I'll try to keep them to 3, 4, 5 triangles or 5, 12, 13s. So what we want to find is we want to find the sine of theta over 2. And we want the exact value. Well, by definition, we have plus or minus square root of 1 minus cosine of theta divided by 2. Cosine of theta from our triangle, negative 3 over 5, and we're also given it up here. So subbing in, we have plus or minus square root, 1 minus a negative 3 over 5, and divided by 2. Now once again, I'm going to challenge you. You can do one of two things. You can enhance your mathematics skills by simplifying a complex fraction, or we'll look at a calculator here too. My only denominator I have is the value of 5, so I can multiply top and bottom by this value of 5. So we have plus or minus square root of, on top, 5 minus a negative, which will turn into a positive. We have minus a negative, that will turn into a positive. The value of 3 all over 10. Which is plus or minus square root of 8 over 10. Which is plus or minus square root of 4 over 5. Which is plus or minus 2 over square root of 5. Once again, we can rationalize this by multiplying top and bottom by square root of 5. So we're left with 2 plus or minus 2 square root of 5 over the value of 5. Now we look at the idea of we have to determine, is it plus or is it minus? Well, how do we determine if it's plus or minus? And this could be all a calculator exercise. If we look at what we are initially given that theta is between 90 and 180 degrees. Theta is between these two measures, 90 and 180 degrees. If theta is between 90 and 180 degrees, what would half theta be in between? Theta is between 90 and 180. So half theta is going to be in between what and what? Well, if we take a look, we divided this by 2 to give us half theta. Using our properties of equality or inequality, we can also do the same with the other two. So theta is between 45, half theta is between 45 and 90 degrees. So what I want you to do on your calculator is pick any number between 45 and 90. And take the sine of that angle. So you take any value between 45 and 90. Take 72. So we have we could take the sine of any, once again, you can take any number you want. 72. Take the sine of 72, we come down to a positive value. So your solution is going to be a positive value. Take the cosine of theta over 2. Okay, you work it. Let's look at one last thing. Before we go, one more thing. Let me show you, your calculator will do some nice things for you. If we look at that fraction underneath the radical, we can quantify and go 1 minus a negative 3 divided by 5. And we can divide this by the value of 2. We can just click and collect that into our calculator. We hit our math button. We hit enter, and it'll take us back to the 4/5. So it will work the fractions for you if you want. It's up to you. You do what you want to do. Okay, cosine half theta, we have plus or minus square root of 1 plus cosine of theta divided by 2. Sub in for your cosine of theta. And it should look very similar to what we just did. The only difference is we have 1 plus a negative 3/5 divided by 2, so we don't have minus a negative. So we're going to have subtraction here. Go ahead and multiply through by your 5. Or once again, if you want to quantify both fractions. Quantify the top and divide by 2. Hit your math button, hit enter. You can do that. So go ahead and find your value, check your answer with somebody around you. Once again, now you're going to take a cosine of any angle between 45 and 90. So find the cosine of any angle between 45 and 90. And just work through the problem. And once again, check your answer with somebody around you. Multiply through by the value of 5. What we're left is plus or minus square root of 5 plus a negative 3 divided by 10, which is plus or minus square root of 2 over 10, which is plus or minus square root of 1 over 5, square root of 1, square root of 5. We're left with 1 over square root of 5 plus or minus, multiplying by radical 5. Radical 5. We're left with plus or minus square root of 5 over the value of 5. That'll be your solution. Once again, if you take take the cosine of any angle between 45 and 90, you will find this to be a positive value. And just food for thought, any angle that you have in quadrant number 1 is going to be a positive value. Now if we take a look at the tangent, theta divided by 2. Once again, you can choose any one that you want. My preference is dealing with 1 minus the cosine of theta divided by sine of theta. That's my choice of using this. Reason why is if you have radicals in here, it's easy to rationalize the denominator if you have radicals with this formula. If you use this formula up here, now you have to worry about conjugates when you rationalize the denominator. This one's a lot easier because we just have a single term. So we're left with 1 minus the sine of theta, which is 4 over 5, divided by cosine of theta, negative 3 over 5. Multiply through by your value of 5. Or, once again, if you use your calculator, that is fine. There's no shame there. Check your answer with somebody around you. Oh, I have those things backwards, don't I? Let's try that again. My bad. We have 1 minus cosine of theta, so we have negative 3 over 5. And then we have 4 over 5 on the bottom. My fault. Sorry about that. So if we multiply through by that, we have 5 plus 3 on top. On the bottom, we have a value of 4. Once again, minus a negative will give us a positive. So we have 8 over 4, which is a value of 2. The other nice thing about using this formula here is you don't have to make a decision about is it positive or is it negative. You don't have to worry about that decision. So it all comes out in the wash for you, where you don't have to worry about putting in values. Homework is on page 138, 139, 15 to 24, multiples of 3. Tomorrow we'll come in, we'll do sums and products formulas. That will be the last set of formulas that we have to deal with. Worksheet on Friday, worksheet on Tuesday, review on Wednesday, quiz either next Wednesday or Thursday. That will finish out your trig identities here. And then I have nothing else for you. QED, as done.